Do you want to learn how to create a Minecraft game from scratch with JavaScript? In this 10-part video series, I'm going to show you step by step how you can create a Minecraft clone with procedurally generated worlds, collision detection, terraforming, and much more. But before we dive into the code, let's take a quick walk through the final product. So on the screen right now, we have the final product of what we're going to be working on. Now, in terms of terrain generation, which is going to be the first two videos that we work on, there's a whole bunch of different parameters that we can set here. So I have this little UI on the side where we can change all of our terrain parameters. So let's say I set the scale to 100 and the world repopulates. So now you can see everything is a bit more spread out. The hills aren't quite as close together. You can also change that scale to be smaller. And you get this very volatile looking terrain. We can change the magnitude of those hills. Let's set our scale back to 40, set a magnitude of 0.5. And we get these very large hills. And we can set magnitude to 0.1. That'll reduce the size of the hills. And we can also control the water level. So we can set the offset to something higher. You can see all the water goes away. We set the offset to 0, basically a giant ocean biome. So all kinds of different parameters that we can choose from here. We also have a seed parameter, which controls the random number generator. So if I set this to 10, you can see it'll generate a completely new random world. In the third video, we'll be adding resources to our terrain. So you can see here, I've chipped away at the hillside a bit and uncovered some stone and some coal ore. So we're going to be using 3D noise to generate these pockets of resources that live underneath the terrain. And we have settings here on the side. We can control the scarcity of these resources. We can control the size and scale of these deposits in each axis independently. So lots of parameters we can tune here to get the effects that we want. So in the fourth video, we'll focus on capturing mouse and keyboard events to move our character around. While in the fifth video, we'll be building our own collision detection. Now, if I turn on the collision detection visualizations, you can get a sense of what's going on here. Our player is represented in the physical world by this bounding cylinder, and we can see some of the blocks that the player is interacting with. So we break the collision detection into 3 separate steps. There's the broad phase, the narrow phase, and the resolution. In the broad phase, we get a list of all possible blocks the player could be colliding with. And these are represented by these red blocks that are highlighted here. So as I move closer to these blocks on the edge here, you can see that they're highlighted red. So these are the potential candidates that our player could be colliding with. We take this list of candidates and then we intersect those blocks with the player's bounding cylinder. As I get close to these blocks, you can see that it's representing the actual collision points of the blocks with the player's bounding cylinder with these little green spheres here. Now, once we get a list of all these collision points, we pass that to the third phase of the collision detection, and that resolves the collisions in order of the smallest overlap to the largest. In the sixth video, we'll be extending our world generation code to create an infinite world that our player can explore. We're going to be implementing the exact same technique that's used in the real Minecraft game called chunking. What we're basically doing is we're breaking our world into multiple chunks. And we're loading these chunks as the player gets near them, and as the player moves far away from other chunks, we'll be removing those from memory. So I've disabled the fog and reduced the draw distance a bit. So you can see that as the player moves, new chunks are being loaded into view. Now in video 7 is where the real fun begins, because we'll start to add terraforming. We'll add the capability of removing blocks, and we can also add blocks. So we'll be using ray casting for that to determine which block the player is interacting with. So if I'm adding blocks, we want to highlight the block adjacent to the block we're pointing at, so we can add a block to the side. And if we're removing blocks, then we want to highlight the block itself that the player is selecting so it can be removed. In the 8th video, we're going to focus on making our world generation a bit more interesting. So we'll be adding in water, we'll be adding in clouds, and of course trees. Now I have some additional controls on the side here. We can control how many trees are populated in the landscape. So if I increase this frequency to 0.1, As our world pops in here, you can see there's a lot more trees. We can also change the minimum and maximum size of the trunks of the trees. I'll increase the range from 2 to 10 here. So we get some very short trees and some very tall trees. And we can also change the canopy size. So we can get some much larger tree canopies. Now this looks a bit ridiculous. We basically just made a bunch of bushes, but if that's what you want to do, that's what you can do. And we also have a control for how dense the canopy is. Now, video 9 will be a bit of a grab bag of new features. First of all, I'm going to show you how to create this animated pickaxe. So when we're removing a block, it'll make this cool little animation. So we'll import that model in. We'll hook up the animation to the mouse click. We're also going to be adding this toolbar at the bottom of the screen. So as I press the 1, 2, 3, the number keys, you can see that it's changing my selection. And this controls the active block, or if we select our pickaxe, that will select that as well. So that'll be a little bit of HTML and CSS to set that up. Finally, and I think most importantly, we're going to be creating a saving and loading functionality. Now I've built this little structure here, and let's say I put a lot of work into this. I want to be able to save this off and come back to this world later. That's what we'd expect of any modern game, right? So I can actually hit F1, and you can see in the bottom left corner, it has saved the game. So it's actually saving the state of the game into local storage. So any modifications the player has made are then saved into local storage in the browser. Now I went ahead and reloaded the browser, and you can see that our stone structure is gone. But if I hit F2, you can see that it now reloads the game. And after some searching, I have found the stone structure that we built. And you can see it is exactly as we left it, and we can continue adding on to it. Now the 10th and the final video is actually going to be a user special. So you guys are going to get to decide what that final video will be. So when I wrap up the 9th video, I'll put a poll out on my community channel. So you guys can go and leave comments there, and you can tell me exactly what you want to see in that 10th video and what new features I should be adding in. All right, so that's a really quick overview of everything that we're going to be working on in this tutorial series. So I'm super excited to embark on this journey with all of you. So without further ado, let's get coding. Now we're going to be using Three.js to build our Minecraft game. And Three.js is a 3D graphics library for JavaScript that wraps WebGL, makes it a bit easier to use. I'm on the website right now, which is Three.js.org. And there's a bunch of examples here. I'm not going to dive into everything that Three.js can do here. Much bigger video than what we want to cover, but there's some very cool things you can do. Here's some basic animations you can look at. Yeah, I just highly recommend going here, checking it out, and seeing the capabilities of Three.js. All right, so I have my Visual Studio Code instance open here. The first thing that we need to do is we need to create our application. Now there's a standard procedure that you can follow for this. So if you go to Three.js.org and go to their installation section, you can see exactly how you go about setting up a project. So we're going to be doing this option 1 here. We're going to be installing with npm and a build tool, and that build tool will be Vite. This will take all of our dependencies, bundle them together, and generate the resultant HTML and JavaScript. If you go back to Visual Studio Code, we can create our app by going npm create Vite at latest. And this will take us through sort of a step-by-step questionnaire. So let's call this Minecraft.js and expand this up a bit here. I'm going to be using vanilla JavaScript for this project and just JavaScript. You can see it's created a folder with our application here. So let's go and open that. Now, before we do anything, we need to install the npm packages. So let's do npm I. And that will install a node modules folder here with all of our base packages listed in package.json. So let's go ahead and just see if we can get the sample application working. So we can run that or run that application using the script here, dev. I'm going to do npm run dev. And you can see that it is now running our application at this address here. Now, if I navigate to this address here, you can see that we actually get an error here, unable to connect. And this is an issue on Macintosh. If you're on Windows, I'm not sure if you have this problem or not, but there's a very easy fix for this. So the host name for my machine is actually not localhost, it's something else. I like to just avoid using the host name entirely and just use the localhost address, which is always 127.0.0.1. So all we need to do here is to set the host in our dev script to 127.0.0.1. And now when I navigate to that address, you can see we have the Vite sample app here. So if I click this button, it'll increment the count. Everything's working. We know that our Vite application is set up. Now we're ready to add the Three.js dependency. Let's go back to our code. We'll stop this here. And before we go ahead and add that Three.js dependency, let's do a little housekeeping here. The first thing I'm going to do is create a new file called vite.config.js. And I'm going to paste this little snippet of code in here. So what this is doing is enabling source maps. So when we're getting any errors in the browser and we're looking at it in the console, we can see the file in line where that error is occurring. Without the source maps, you don't get that information. So first things first, we always add this in. The next thing that we need to do is to clean up all the files associated with that sample app. I'm going to go ahead and clean out all the unneeded cruft. So I went ahead and deleted the counter file and the SVG, and I went in our main.js file, cleaned all that out, and cleared all of the styles to no styling. I like to keep all of my scripts in a folder called scripts. So I'm going to create that folder, and I'm going to move our main script into there. Now in our index.html file, we need to link to our styles as well as update the path to our main.js file here. So we'll just update that. That's now pointing to the correct location. And I'm also going to add a link to our style sheet. So I went ahead and added a link to our style sheet, and I also changed our application to the title to minecraft.js. Now, if we go ahead and run that dev command again, and you can see that we just have a blank white canvas here, and our page title is minecraft.js. With all of that out of the way, we're now ready to install our Three.js dependency. Let's go ahead and do that. We'll do npm install save 3. And if you go into our package.json, you can now see that we have our Three.js dependency added here using the latest version. So let's go ahead and set up just a very basic scene with a rotating cube. So first we need to import our Three.js library. And we do that with this line here. And then we're going to set up the renderer. Let's create a new constant for a renderer, and that'll be a WebGL renderer. And we'll just do a few setup things here. We're going to set the pixel ratio to the pixel ratio of our device. That just makes sure everything's scaled appropriately. And then we're going to set the size of the renderer to the inner width. The inner width and the inner height of our window. Finally, we need to take the output of our renderer, that render target, and we need to attach it to the DOM. We'll do document.body penchild. Then we'll get the DOM element associated with our renderer. The next thing that we need to do is to set up our camera. So let's create a new constant for the camera. This is going to be a perspective camera. So there's a few parameters for this. The first one is the field of view. We'll pick 75 degrees for that. That's the value that I kind of like to work with. And then the aspect ratio is the inner width of our window divided by the inner height. And finally, we need to set the near and the far plane. So the default values for this are 0.1 and 2000. So we're just going to stick with those default values. Let's go ahead and set the starting position for our camera. It'll be camera.position.set. And that will be just 2, 2, 2. So 2 in the x-axis, 2 in the y, and 2 in the z. And then we want our camera to be looking at the origin. Let's close the console here. We don't need that right now. Now let's go ahead and create that basic scene. So we need to create a new scene object. And then we need something to actually render in our scene. So we're going to do just a cube, a little green cube, and we're going to spin that cube over time. So our cube is represented by a mesh, and a mesh is a combination of geometry and a material. So geometry is kind of the structure of the thing. That's all the vertices, all the triangles. The material tells the renderer how to actually draw that geometry. So what color it should be, should there be, transparency, things like that. So there's some built-in geometry with Three.js. We can use the box geometry here. We'll just use the default values, which creates a 1 by 1 by 1 cube. And then we'll create a new mesh basic material. And let's give this a color of green. So we'll finally create our cube here. This will be a new mesh. And the mesh takes in a geometry and a material. So we'll just pass in the geometry and the material here. Finally, we need to add that cube to our scene. So we'll do scene.add, and then we'll pass in that cube. The final thing that we need is our render loop. And we'll just create a function here called animate. And in our animate function, first thing that we need to do is request the next animation frame. So this happens asynchronously, doesn't really matter where we put it. We can throw it right here. And then we're going to update the rotation of our cube in each render frame. So do cube.rotation.x plus equals 0.01. And then we'll do the same for the y. Now finally, we need to actually render our scene each frame. So for the renderer, we'll call the render method. And this takes in our scene that we want to render and the camera that we want to render it with. So from what perspective do we want to render that scene? Then finally, to kick off our render loop, we just call animate at the bottom of our main file here. Now we need to go ahead and run our application. So let's go ahead and bring up the terminal and we'll do npm run dev. Now I already have my window up over here and there we have our spinning green cube. So there we have it, Minecraft. We have our cube right there. Just kidding. So obviously we need a bit more work here. The first thing we need to do is remove this white border. So let's go ahead to our CSS styles here. And for our body, we'll just set the margin to 0. Now the nice thing about Vite, when we're doing that run dev command, anytime we make any changes to our files, it's going to go and re-update, rebuild the application. And so when I go over here, you can see that everything is already updated. Another thing that we need to do is to handle resizing of the window. So let's, if I open up the console right here, you can see that our scene isn't really resizing. So let's go ahead and fix that. We'll go back into our main file. And then at the bottom here, after animate, let's create a event listener. So anytime our window is resized, we want to go ahead and update our camera and update our renderer to tell it about the new window size. So we'll need to update the aspect ratio of our camera first. And as before, this is the inner width and the inner height of our window. Divide the height into the width. And then when we update any parameter on our camera, we need to call update projection matrix. And finally, we need to set the new size of our render target. That'll be the inner width and inner height of our window as well. All right, there we go. So now if I go ahead and bring up the console, you can see, let's move this over to the right here. You can see as I move this, our scene is resizing. Now let's add a bit of interactivity here. We want to be able to kind of move our cube around and manipulate it. Right now, if I drag my mouse, this doesn't really do anything. The cube's rotating on its own. Now there's a built-in Three.js add-on that we can use called orbit controls. So this allows the camera, kind of as the name implies, we can use the mouse to orbit around the cube by dragging our mouse around. It also handles zoom, it handles rotation, and handles panning. So it's a really nice thing to just add in your project right away. So the first thing that we need to do is to import orbit controls at the top of our file. And that is actually going to be imported from the Three.js add-ons. That's three add-ons, controls, orbit controls.js. And then right after our camera, let's define our controls. And this will be new orbit controls. And the constructor for this, we need to pass in the camera as well as the DOM element of our renderer. So before we go and look at everything, let's just turn off the rotation of the cube so it's not quite so confusing. So if you go look at our scene now, you can see our cube had stopped rotating, but now I can drag the mouse around. You can see that the cube is rotating. I can zoom in, I can zoom out, use the right mouse button to pan around. So that's really nice. This will help us as we start designing out our Minecraft world. So right now our cube is kind of flat. It's not very interesting. There's no shading or anything like that. So let's go ahead and add some lights to our scene. So below our scene setup code here, I'm going to create a new function called setup lights. And we'll add a few different lights here. I'm going to add some directional lights as well as an ambient light. So I went ahead and created a few lights here. If you'd like to pause the video and copy this code down, you can go ahead and do that right now. So I've added two directional lights. This is basically like a sun. The light comes in from a certain direction. It doesn't matter how far the object is away from that light. It's going to get the same intensity of light on it. I've also added some ambient light. So anything that isn't hit by directional light will still get a little bit of light. And that kind of mimics the diffuse light that we see in the real world. The last thing we need to do, or second to last thing, is we need to call setup lights here. We'll call that right before we start animating. So I say second to last because if we go and look at our cube now, it looks the same. Nothing's really changed. This is because we're using a basic material. So the basic material by default has no shading. So we can fix this by changing it to a Lambert material. So this is a type of shaded material, and this just happens to be the most performant one offered by Three.js. So now if we go ahead and look at our cube, you can see we have some nice shading here. As I rotate this around, it's a bit clearer to see where the edges and the corners of the cube are. So now we have some nice lighting. We can actually see what's going on with our world. So while technically we have the smallest game of Minecraft on our screen right now, things would be a bit more interesting if we had more cubes on the screen. So let's go ahead and create a whole floor of cubes. So below setup lights, let's create a new function called setup world. And we'll pass in a size parameter to control the width and the height of the world. And we'll just do a doubly nested for loop here. So we're going to iterate over the X and the Z axes. Let's go ahead and take the code we have up here. We're creating these cubes. And let's add it in down here. Now, when we create a new cube, we want to go ahead and take the position of that cube and set it to X, 0, and Z, and then add that cube to the scene. Now we need to go ahead and call our setup world function. We'll do that here, and we'll just do a 32 by 32 world. So now if we go and look, you can see we have a much larger world here. So it's creating that 32 by 32 array of blocks and laying them out in the XZ plane. So this is the beginnings of our Minecraft world. Eventually this is going to be some cool terrain with trees and water on it, but this is where we're starting with. I'm going to go ahead and update our camera to be a bit more zoomed out here when we initially load the scene, just to make things a bit easier. I'll just do -16, or let's say -32, 16, -32. And then instead of changing the camera look at, we need to change the orbit controls. So the target, set that to the middle of our world. Then anytime we make changes to the controls, we need to call controls update. That's a bit better. Now when we load everything, we can see that our world is centered on where the camera's looking at. So things are a bit dark right now. Let's go ahead and set the sky color. So all we need to do is to go to our renderer and do set clear color. And we'll change that to kind of a lighter shade of blue. That'll be 80, E0, E0. There we get kind of a nice sky blue color. So to wrap up this video, let's go ahead and refactor our world code into a new file. I'm going to create a new file under scripts called world.js. And in here, I'm going to import our Three.js dependency. Then we're going to create a world class, and this is going to contain all of the logic for generating our world. So I went ahead and set up a very basic class here. So our world is actually extending from the three.group object. So a group is really just a collection of objects within our scene. Our world is just an abstraction really of all of the different blocks. And that's what group really is for. I've added a constructor here where we're passing in the size of our world. If no size is passed in, we'll default to 32 by 32 blocks. Always need to call super when we're extending from a superclass. And then we're just setting the size of our world as a class property here. Let's create a function called generate. And then I'm going to take our world generation code. Let's just cut that out from our main file and paste that here. So just making some slight tweaks. You need to now reference the size on this. And instead of adding to the scene, we're actually adding the cubes to the world itself. And let's be a bit more clear here. These are actually blocks, not cubes. Blocks, kind of the Minecraft terminology. And we also need to bring over the geometry and material for our blocks. So I'm going to grab those, and we will just paste those outside the class here as constants. All right, so that's all we need to do to refactor our world generation code. Let's go back to main, and let's create our world here. So VS Code automatically imported our world module. And then let's go ahead and call world.generate right here and add our world to the scene. And then finally, we need to go and remove our old setup world function here. And there, we should have the exact same scene that we had before. All we've done is just refactor the code, and this will make it a lot easier to stay more organized as the project evolves. So I think that's enough for this video. We got our Vite application set up. We got Three.js dependency added to that. We created a very basic world here. So we're one step closer to creating our Minecraft clone in JavaScript. I hope this has been a helpful tutorial for you. And a second video will be coming out soon. We'll get more into the world generation, how I'm going to create that terrain. So if you want to be notified when that new video comes out, please hit the subscribe button below and like this video if it's been helpful for you. So until next time, take care, everyone. Thanks for watching.